On July 30th, 1976, a NASA scientist named Gilbert Levin sat in front of a strip chart recorder and watched a needle jump. In a way, it was never supposed to jump if the soil sample in front of him was simply dead, sterile dirt. He was looking at data beamed back across roughly 200 million kilometers of space from a lander sitting on the surface of Mars, and what that needle was telling him looked, by every reasonable interpretation available at the time, exactly like the signature of living microorganisms. 50 years later, in 2026, that exact moment is still one of the most contested, unresolved questions in the entire history of space exploration. And this year, of all years, new analysis has come out that makes the mystery even stranger than it was before. NASA has never definitively said Viking found life on Mars. NASA has also never been able to fully explain away what it actually saw. And the scientists who have spent decades staring at this 50-year-old data are now more divided than ever about what really happened on that alien soil back in 1976. To understand why this mystery has refused to die for half a century, you first have to understand exactly what NASA was trying to do with the Viking missions in the first place. Because the ambition involved was almost unbelievably bold for its time. Viking 1 and Viking 2 were twin spacecraft, each consisting of an orbiter that circled Mars and a lander that touched down directly on the planet's surface. Viking 1 landed on July 20th, 1976, exactly 7 years to the day after Apollo 11 put the first humans on the moon, a date NASA deliberately chose for its symbolic weight, though the agency ultimately pushed the actual landing back several days because engineers wanted more time to study potential landing sites for hazards rather than rush the touchdown purely for a headline. Viking 2 followed a few weeks later, landing at a separate site roughly 6,500 kilometers away. Together, these two landers represented the first time any spacecraft from Earth had successfully operated on the Martian surface for an extended period, sending back not just photographs, but real scientific data gathered directly from Martian soil using instruments packed onto each lander. And buried inside each of those landers sat something genuinely radical for 1976, 3 separate biology experiments, purpose-built specifically to answer one of humanity's oldest questions: is there life on Mars? This wasn't a side project tacked onto a geology mission. Searching for life was one of the central goals of the entire multi-billion-dollar Viking program, and NASA assembled a team of brilliant, occasionally quarrelsome scientists to design experiments capable of detecting microbial life using nothing but a robotic arm, a handful of sealed test chambers and radio transmitters relaying results back across tens of millions of kilometers, with no possibility of the scientists ever physically touching the samples themselves. It's worth sitting for a moment on just how audacious it was for NASA to even attempt this in the first place, given the technology available at the time. Remember, this was 1976. The Viking landers were operating with computing power that would be laughably primitive by any modern standard, sending commands and receiving data across a communication delay that stretched anywhere from roughly 5 to 20 minutes one way, depending on the relative positions of Earth and Mars at any given moment. There was no possibility of real-time troubleshooting, no chance to reach out with a robotic hand and adjust an instrument if something looked slightly off. Every single experiment had to be designed, built, tested, and essentially locked in years before launch, then trusted to operate flawlessly on an alien world tens of millions of kilometers away, with mission scientists back on Earth able to do nothing but wait, watch the data trickle in, and hope the hardware performed exactly as designed. Against that backdrop, the fact that Viking's biology experiments produced any usable data at all, let alone data ambiguous enough to still be debated 50 years later, is a genuine engineering triumph, even setting aside the question of what that data actually means. The most famous, and by far the most controversial, of these 3 experiments was called the Labeled Release Experiment, designed and championed by a scientist named Gilbert Levin. The concept behind it was elegant in its simplicity. If Martian soil actually contained living microorganisms, and you fed those microorganisms a nutrient solution laced with radioactive carbon, any living organisms present would metabolize that nutrient, the same way life does everywhere on Earth, and in the process, they would release radioactive carbon dioxide gas as a byproduct. Levin's instrument was built to detect exactly that gas, scoop up a sample of Martian soil, seal it in a small chamber, add the radioactive nutrient solution, and then simply watch to see if a telltale burst of radioactive gas appeared in the chamber afterward. The unmistakable fingerprint of metabolism. When the actual results came back from Mars, they were, in Levin's own words, remarkable. Both landers, at 2 completely separate sites nearly 6,500 kilometers apart, produced a fast, strong, unmistakable release of radioactive gas the moment the nutrient solution touched the soil. It looked, on paper, exactly like what a biologist would expect to see if living organisms in the soil were rapidly consuming the nutrients and breathing out the labeled carbon. The response was so immediate and so pronounced that, for a brief electric moment, some members of the Viking science team genuinely believed they might be looking at the first direct evidence of life beyond Earth in the history of human civilization. But before anyone popped champagne, the same experiment ran a critical control test, and this is where the story starts to genuinely twist. NASA's protocol called for heating a second identical soil sample to extremely high temperatures before running the same nutrient test, a process designed to sterilize the sample and kill any living organisms that might be present. If the gas release seen in the first test really was caused by biology, the heat-sterilized control sample should have produced no reaction at all, since any microbes would have been cooked to death before the nutrients were ever introduced. Sure enough, when the heated control sample was tested, the strong gas release almost completely disappeared. On the surface, that looked like exactly the kind of confirmation a biologist would want, a positive result from live soil, and no reaction from soil that had been sterilized by heat. It's precisely the kind of control and response pattern you'd expect if life were genuinely present. And yet, almost immediately, a second instrument on the very same landers threw a massive wrench into that clean, exciting story. Sitting alongside the labeled release experiment was a completely different piece of equipment called a gas chromatograph mass spectrometer, commonly shortened to GCMS, an instrument specifically designed to detect organic molecules, the carbon-based building blocks that, as far as we understand biology anywhere in the universe, are considered essential ingredients for life as we know it. The GCMS worked by heating Martian soil to extremely high temperatures, vaporizing whatever chemical compounds were locked inside it, then breaking those vaporized compounds apart and precisely measuring the resulting fragments to identify exactly what molecules were present. If Martian soil genuinely contained living organisms, even simple single-celled microbes, you would expect the GCMS to detect at least some trace of organic material, because every known form of life on Earth, living or dead, leaves behind organic, molecular signatures. The Viking GCMS found essentially none. Not the strong signal you'd expect from a soil full of actively metabolizing organisms. Nothing meaningful at all. That contradiction became the 50-year-long thorn stuck in the side of this entire mystery. Here you had one instrument screaming what looked like a biological signal, and a second instrument, run on the exact same soil, finding no trace whatsoever of the organic molecules that biological signal should have logically left behind. Confronted with that direct contradiction, the official Viking science team ultimately concluded that the labeled release results, while genuinely puzzling, were most likely caused by some kind of unusual, still unidentified chemical reaction. Rather than actual biology, some reactive compound in the Martian soil capable of mimicking the chemical signature of metabolism without any living organism being involved at all. NASA's official position for the past 50 years has essentially been that Viking found strange, unexplained chemistry on Mars, not life. It's worth pausing here to understand what the other two biology experiments on board actually found too, because the full picture involves more than just the labeled release result and the GCMS arguing with each other. Alongside the labeled release experiment and the GCMS, Viking also carried a pyrolytic release experiment and a gas exchange experiment, each designed to probe Martian soil for different possible signatures of biological activity. The gas exchange experiment looked for changes in atmospheric gases like oxygen and carbon dioxide after exposing soil to a nutrient-rich, humid environment, essentially checking whether something in the soil would start behaving differently once given food and moisture. That experiment produced a genuinely strange result of its own, a sudden burst of oxygen, released almost immediately after the soil was first exposed to moisture, even before any nutrients were added. Many scientists have long argued that particular reaction looks far more like a straightforward inorganic chemical process, Martian soil simply reacting to water in a way that doesn't require biology to explain. And that interpretation has generally been the or widely accepted one for that specific instrument. The pyrolytic release experiment, meanwhile, tested whether soil samples could take carbon dioxide from a simulated Martian atmosphere and incorporate it into organic compounds, mimicking a very basic form of photosynthesis. Its results were weaker and more ambiguous than the labeled release data, generally interpreted as a modest positive signal, but nowhere near strong enough on its own to settle any argument either way. 2 of the 3 biology experiments, in other words, produced results generally read as non-biological, while the third, Levin's labeled release instrument, produced by far the strongest and most stubbornly biological-looking signal of the entire trio, which is exactly why it has remained the focal point of this entire 50-year debate. But here's the thing that makes this story genuinely fascinating rather than simply a closed case from half a century ago. Gilbert Levin himself never accepted that conclusion, not for one single day of the remaining 45 years of his life. Levin continued arguing, right up until his death in July of 2021 at the age of 97, that his experiment really had detected living microorganisms on Mars back in 1976, and that the scientific community's rush to explain the results away with an undiscovered mystery chemical was itself the far less plausible explanation. He pointed out repeatedly that the response pattern his instrument recorded matched biological metabolism far more precisely than any proposed chemical alternative anyone had ever actually demonstrated in a laboratory. Decades of attempts by other researchers to replicate the exact Viking soil response using purely chemical means, without any biology involved, kept coming up short, never quite reproducing the precise pattern seen in the original 1976 data. Now here's where 2026 comes in, and where this 50-year-old mystery genuinely gets stranger rather than finally settling down into a tidy resolution. This year marks the 50th anniversary of the Viking landings, and that milestone has triggered a wave of fresh scientific re-examination, including a dedicated special anniversary collection published in the journal Astrobiology, specifically revisiting the labeled release experiment with the benefit of everything we've learned about Mars in the 5 decades since. And the picture emerging from that re-examination is genuinely more complicated and in some ways more provocative than the story most people have heard for years. Part of what's driving this renewed debate is everything Mars rovers and orbiters have discovered since 1976, discoveries that would have completely reshaped how the original Viking team interpreted their own results, if only they'd known about them at the time. In 2008, NASA's Phoenix lander discovered that Martian soil contains a class of chemical compounds called perchlorates, a family of highly reactive oxychlorine chemicals that essentially do not naturally occur in significant concentrations anywhere on Earth's surface. Perchlorates are exactly the kind of aggressive, reactive chemistry that could plausibly explain strange results in a life detection experiment. And their discovery gave a huge boost to scientists who had long argued the Viking results were chemical, rather than biological in origin. But here's the twist inside the twist. Later research demonstrated that perchlorates, under the specific conditions present during the Viking GCMS heating process, would have actually destroyed any organic molecules present in the soil sample before the instrument ever had a chance to detect them, essentially incinerating the very evidence the GCMS was searching for. In other words, the same chemical that seemed to explain away the labeled release signal might simultaneously explain why the GCMS found no organics at all, even if organic material, and by extension possibly even life, had genuinely been present in the original sample all along. That single realization reopened the entire debate in a way nobody fully anticipated. If Martian perchlorates were destroying organic molecules during the GCMS heating process, then the absence of detected organics doesn't necessarily prove the absence of life the way scientists had assumed for decades. It just means the GCMS, given the specific chemistry of Mars and the specific way the 1976 instrument was designed to operate, may never have been capable of detecting organics, even if they were sitting right there in the sample the entire time. Suddenly, the central pillar holding up the official explanation, the idea that no organics meant no biology, looked considerably shakier than it had for the previous 3 decades. Adding even more weight to that reconsideration, subsequent Mars missions have independently confirmed that the planet does contain complex organic compounds after all, discovered by instruments on later rovers like Curiosity, instruments built with far more advanced technology than anything available on the original 1976 landers. Mars, it turns out, is not the organically barren wasteland the original Viking GCMS results seem to suggest. There are genuine organic molecules embedded in Martian rock and soil in multiple locations across the planet. That discovery alone doesn't prove Viking found life, but it systematically dismantles one of the strongest arguments that had been used for 50 years to argue Viking definitely didn't. It also matters that our broader understanding of where life can survive on Earth has shifted dramatically since 1976, and that shift feeds directly back into how seriously scientists now take the possibility of Martian microbes. Back when Viking launched, biologists still generally assumed life required relatively gentle, temperate conditions to survive, something reasonably close to the environments most familiar to us here on Earth's surface. In the decades since, researchers have discovered so-called extremophile organisms thriving in conditions that would have seemed utterly impossible for life just a few decades earlier. Microbes living inside solid rock miles underground, bacteria surviving in boiling acidic hot springs, organisms found flourishing in Antarctica's driest, coldest valleys. Environments deliberately chosen by NASA's own early astrobiologists, specifically because they resembled Martian conditions closely enough to test Viking's instruments before launch. Each new extremophile discovery back on Earth has quietly nudged the scientific community's collective sense of what's biologically plausible on Mars a little further away from outright dismissal and a little closer toward genuine open-mindedness. Some researchers have pushed this re-examination even further, building elaborate theoretical models to explain exactly what kind of Martian life could plausibly account for everything the labeled release experiment actually recorded. 1. Prominent researcher developed a specific hypothetical model nicknamed BARSOOM, an acronym for bacterial autotrophs that respire with stored oxygen on Mars, named as a nod to the fictional name for Mars used in Edgar Rice Burroughs' classic pulp science fiction novels. The BARSOOM model proposes a specific kind of theoretical Martian microorganism that would use a form of photosynthesis during the Martian day to produce and store its own oxygen internally, then essentially go dormant and metabolically quiet during the planet's brutally cold nights, only reawakening the next day to use that stored oxygen and repeat the entire cycle. It's a genuinely creative piece of scientific speculation, built specifically to explain why Levin's experiment might have detected something that behaved biologically without requiring Martian life to look anything like familiar Earth microbes. To be absolutely clear here, none of this new 2026 anniversary research amounts to definitive proof that Viking found life on Mars. Plenty of serious credentialed scientists remain firmly convinced the entire episode was ultimately chemical rather than biological, and the debate genuinely splits the astrobiology community, even now, 50 years on, without anything close to unanimous consensus on either side. What has changed, and changed quite significantly in just the past year or two, is the confidence level surrounding the original dismissive conclusion. 50 years ago, and for a long stretch of the decades that followed, the mainstream scientific position treated the Viking-labeled release results as essentially settled science, an interesting historical curiosity explained away by an unidentified soil chemical reaction, case closed. Today, thanks to everything Phoenix, Curiosity, and multiple other missions have taught us about Martian perchlorate chemistry and the genuine presence of organic compounds across the planet, that dismissive certainty has eroded considerably. The honest, current scientific position, as reflected directly in this year's 50th anniversary retrospective research, is closer to genuine uncertainty than confident denial, which is a remarkable place for this story to land half a century after the original data first came back from Mars. There's something deeply human buried inside this story too, beyond the pure science of it. Gilbert Levin spent nearly half a century of his professional life defending a conclusion that the majority of his own scientific community rejected, watching younger researchers build entire careers explaining away his results and never once wavering. From his interpretation of the raw data his own instrument recorded on that Martian soil in 1976. He died in 2021, still convinced he had witnessed the first genuine evidence of extraterrestrial life in human history, 5 years before a new generation of astrobiologists would begin taking his original argument more seriously than at almost any point since the Viking missions first landed. It's the kind of vindication, however partial and however contested it still remains, that very few scientists ever live long enough to see. And this is precisely why NASA has spent so much of 2026 revisiting Viking rather than simply celebrating an old anniversary and moving on. Every current and future Mars mission planning document circulating within the agency now explicitly references the unresolved Viking results as a central scientific justification for exactly why a dedicated life detection mission needs to happen before humans ever set foot on the Martian surface. Once astronauts start walking around on Mars, contaminating the environment with Earth microbes carried on their suits, their equipment, and their own bodies, the ability to cleanly detect any indigenous Martian life, if it exists at all, becomes exponentially harder, possibly forever. NASA scientists working on future astrobiology missions have said directly and publicly that resolving what Viking actually found or didn't find back in 1976 has become significantly more urgent now that serious human Mars mission planning is genuinely underway, rather than remaining a purely academic curiosity confined to historical journals and anniversary retrospectives. Martian chemistry only exists because of everything humanity learned from all the Mars missions that came after Viking itself. In a very real sense, the Viking landers had to wait 50 years for the rest of the space program to catch up enough to properly understand what they'd actually found back in 1976. That's an unusual kind of scientific patience, an experiment whose true meaning may only become clear across multiple generations of researchers, spacecraft, and technological advancement, rather than within the lifetime of the mission itself. So where does this 50-year-old mystery actually stand right now in the second half of 2026? NASA has not reversed its official position. The agency has not announced that Viking discovered life on Mars, and it likely won't make any such announcement without dramatically stronger, more direct evidence than a 50-year-old reinterpretation of decades-old chemistry, no matter how compelling that reinterpretation might be. But the scientific ground, underneath the original dismissive explanation, has shifted more in the past several years than it had in the previous 4 decades combined. New evidence about Martian perchlorates, new confirmation that organic compounds genuinely exist across the planet, and a fresh, dedicated 50th anniversary re-examination of the original raw data have all combined to make one of the oldest cold cases in planetary science suddenly, genuinely, live again. What began as a strange needle jump on a strip chart, Recorder in 1976 has become one of the most stubbornly unresolved mysteries in the history of space exploration. And after 50 full years, it somehow just got stranger rather than simpler, leaving the next generation of Mars missions with a very old, very unfinished question still waiting for a real answer.